Hello, everyone.
Good evening, sir.
Can you hear me? Am I audible to all?
Yes, sir.
Okay, great. Okay, so let me share my screen. Excuse me. Okay, so yesterday we were discussing about lenses. We started lenses here. Okay, in lenses like two types, convex and concave. So this is our like new topic of this one, ray optics, new topic of the ray optics. So convex and concave. In convex, biconvex means both side convex. Equiconvex means both radius will be same. Here radius might be same, might not be same. Generally, we will use equiconvex only in our your experiment and whatever you're doing. It will be equiconvex. Here plano convex, one side plane, one side curved. So when it is a plane and when it is a curve. So if it is a curve, we can just make a circle and say that this is the radius. But if it's a straight line, when it's a plane side, plane mirror, we cannot meet those as a circle. We can meet only at infinite. So which is, it's only at infinity. Same goes for concave. Excuse me. Both side curved, they have two radiuses, and both side curved with equal radiuses. One side plane, one side curved. So plane, again, it is infinite. So I have drawn on this side, not necessary it is on this side. It can be like this also. One side plane, it can be this. Any of the side it can be. Now, next one, concave or convex. Like both are like concave or convex. Mixture of both, concave and convex. These two. Now, these are diverging rays and one are converging. This side, this one, converging. This is diverging. But these are diverging and these are converging. If you remember this ray diagram from your 10th standard, I'll show you one. Convex lens, we used to draw this way. So it is called converging. We are talking about this two, first two. And this one, it is diverging. Are you able to understand?
Yes, sir.
Others?
Yes, sir.
Okay. Okay. If you want to make a note, you can make a note of it. Done? Okay. Now let's see aperture. Aperture is the diameter of it. So diameter in the sense, let me draw again. Instead of same, if I draw here convex, so this is your diameter, center line which we are drawing, there is a diameter. You can say. So this is the aperture of it. So diameter is the aperture of get lenses, whatever lens we are drawing. Like not necessarily this, I drew a convex, but it can be concave also. And even like the mirror also. It's not necessary here, this lenses. It can be any. Okay, so let's see here. Reflection by lenses and lens maker formula. If you're writing, I'll wait for you, or else I'll move to next. Okay, so this is your lens maker formula. So how to get this? Like it's simple only. Same way like a triangle and all that we will see. Let me draw one lens. Let me show you one. Remaining you can do it the same manner. So this is your lens. It's moving from, let's take here rarer. This is your denser. So rarer to denser. So object distance or position. Let's draw here object. Here we are getting image. And some centers. We'll draw here. Let's name it some C1, I. There will be reflected image here also. That is I1. We can take. Now this is your denser medium. I mean to say this lens denser medium. Now this is your rarer medium. So it's moving from air to glass and glass to air. Air to glass and glass to air. Oh, I wrote here one, then we can write here two. Okay. By our formula, N2 by V equals to N1 by U equals to N2 minus N1 by R. This formula we have. Okay. Do you remember that?
Yes, sir.
Yeah. So now what we'll do here, we'll consider this side, left side here, one mirror and other side. Same way, how we will do, how we used to do, like same manner. We'll consider this side here, N2 minus N1. Oh, this is not equal, I'm sorry. This should be minus sign here. This should be minus. If we consider on left side, like this is a rarer and denser, we're considering this one, rarer and denser. Now, if you consider the other side, I'm talking about this one here, other side, denser and rarer. Same formula, but it will just change. It's moving from denser to rarer. If you know, like it's moving from rarer to denser. Even you have studied in 10th standard, it's light refraction, same manner. So here it will be N2 by U. Yeah, it will change. N1 by V minus N2 by U equals to N1 minus N2 by R2. So this let this be R1. Let this be R2. So here we need image 1. So let's take image 1 here. This is R2. So if you want to make this common like this, what we'll do here? We can multiply. But okay, here this will change. This will change because see, this from here there is an object. Listen this very, very carefully. Okay, this is only most confusing part. This is the object here. It is giving some image in this side, on this side of the lens. Because of this one, we are getting some image somewhere. We don't know. Now that image is the object for next part. Okay, that image is the object for next part. So what is the image name we gave? V1. So here also we will write, instead of U1, we will write V1. Okay, don't forget this one. This image is the object for next case or next transition. Now, if we want to change this sign convention, I want this N to V1 here minus V. So we can just multiply sign N2 by V1 minus N1 by V, N2 minus N1 by R2, because I just want to simplify this to make it easier. That's it. Now, if we subtract this two, this will get cancelled. No, this will not get cancelled. This two will get cancelled. Okay, let's see. This R2 only, na? Yeah. If we subtract this one, this is your number 2. Let's take this is your number 1. If we subtract this 2, what are common terms here? U minus 1. Yeah, V1 will get cancelled. Yes. So it will become N1 V. Come on, help me with this one, subtraction. We're subtracting 2 minus 1. N1 V, N1 by B, V, then U. Is it right? This will get cancelled. V1, I'm taking this value and this equals to N2 minus M1 will be common, right? Will be common. So 1 by R2 minus R1. No. R1 minus R2, we're subtracting, it will be minus sign. Okay, I didn't interchange this one. Minus R2. 1 by R2. So if I take this N1 here and bring it here, so it will become 1 by U minus, 1 by V minus 1 by U. N2 minus N1 by N1, 1 by R1 minus 1 by R2. So this is your F, sorry, 1 by F. And 2 by N1 minus 1. So this is your mu N2 1. One by R1 minus 1 by R2. So this is what formula we will get. Yeah. Mu minus 1, 1 by R1 minus 1 by R2. If you want to make a note of it, or else we can move to next thing. Yeah, by the way, you understood everyone? Yes or no? Am I audible,
Yes,
right?
Yes, sir. Yes,
Okay.
sir.
Okay. Others?
Yes, sir.
ठीक है. So this we did because till 10th standard we were just taking it, okay, lens, it is a lens, we are just passing through it and we are just using it. But now we have to make it transition, because this is the lens. So it's moving from air to glass, then again glass to air. So there are two transition here. Okay, make a note of this calculation. Two minus one. Madhusudan, are you writing?
Yes, sir.
Okay. What about Samhita?
Done, sir.
Done?
Yes.
Okay. And Vishnu, are you able to understand?
Yes, sir. Yes, sir.
ठीक है. What about Aditi? Okay, then let's go next. Will erase this later. Okay. I guess everyone know magnification. You already studied in 10th standard too. Magnification V by U for lenses. For mirror, minus V by U. Don't forget that. For mirror, minus V by U. Okay. Now, next thing you need to remember about focus. Whenever we are solving numericals, this is very, very important sign convention. Because formulas are easy, numericals to solve easy, we know how to solve, but you'll make mistake in formulas. So what to do here? Just remember that left side positive, left side negative, right side positive, everything in the sense, let me make clear here. Whenever we are talking about distance, okay, and whenever we are talking about size or whenever we are talking about size or height, this is your size comma height. This is for focus, object, distance, image, distance. Okay, focus, object distance, radius of curvature, center of curvature. What else we have? 2F, F, whatever we are saying names. Depends upon how they are giving in question. This this one is above principal axis, below principal axis, positive above, below negative. This is for height or size, height of an image. Means how much long it is, positive, negative. And we will keep everything on left side. Object will be on left side. We'll start our object on left side. So negative and height of object will be positive. See, left side and upright. This thing is fixed. Now, in some case, they will ask particularly, okay, object is in somewhere else. Then you have to solve according to that. And in some special case, like telescope and all that, our object will be different. So there also we have to consider something else. We'll see that also that time. But for now, understand this one. Is this sign convention clear with everyone? Is anyone having doubt in sign convention? Bachcha log, are you listening?
No doubt, sir.
Others? Okay then. Excuse me. No power of lens. Okay. We have another class also. I keep forgetting. Okay, we'll finish this one, then we'll wind up. Because 45 you have math class. And you can join with the same link, okay, Vishnu?
Okay, sir. Okay, sir.
Okay. Power of lens. Ability to converge or diverge. So diverge what? Rays. It can, how much ability it has to converge or diverge the rays. That lens has ability to converge or diverge. Unit you know already, diopter, which is 1 by f. Power is 1 by f, power of lens. Reciprocal of focus. Okay, guys. Then see you in next class. You have to join for math class now. If you're done writing, we can end the class here. Is it done?
Yes, sir.
Yes, sir.
Others too? Samhita, Madhu, Sudan, and Aditi? Okay.
Yes.
Okay, guys. See you on next class.